Combined pipelines are extremely powerful and flexible. However, sometimes when things aren't going the way you expect, it can be a little bit hard to find out what's going on. So let's take a look at a few techniques we can use for gaining valuable insight into how a pipeline is operating. So I have an example application here that has a pipeline in it, and it has a few problems. So we're interacting with the Star Wars API, which is a free API you can use to explore objects in the Star Wars universe. In this case, we're going to be fetching planets. And the response looks kind of like this, where we get a planet list, and it has a count of how many total planets there are, and there's going to be 60 we'll be working with. And then it'll give us an array of the planets for this particular page. So there'll be 10 planets in the result here. And then it will give us a URL we can fetch to go fetch the next page of results. And our planets, they have more information than this, but we're just modeling the name and some residents for right now. So back over here on our view controller, let's go ahead and run this and see what is happening. So here you can see we are getting this loading indicator. So this part is working, and we're calling fetch planet page. So it should be fetching this first page of planets, but nothing's actually happening here, and I'm not quite sure why. So let's take a look at what we might do to diagnose this particular problem. For instance, maybe it's not getting this far, which means maybe this isn't completing, or maybe it's not delivering any results. I'm not really sure what's going on here. Now, sometimes it can be problematic because you might want to set a breakpoint on a particular step in a pipeline, but unfortunately it's not going to work like that, because when you call this line of code that you're just setting up the pipeline, this isn't actually what's happening when it's running. So there are a few techniques we can use for that. One of them is actually the breakpoint operator. And the breakpoint operator is actually a little bit misleading. And we haven't seen it so far in this course, and we'll probably see why in just a second. But basically, you might be tempted to just do this, and that seems like it might be pretty promising, like maybe the debugger will stop right here. But unfortunately, that's not the case. Breakpoint is actually a method that takes some optional blocks here. And so if you don't pass any of the blocks, it does nothing. So that's the first thing that might be a little bit misleading. So we can say receive subscription, and we get the subscription and we return a bool. Or we can receive the output, in which case we get the planet list that's coming out of this, and we return a bool. Or we receive the completion, we return a bool. So in this case, we can optionally implement any of these blocks, and you can say, okay, when I get the subscription, I can maybe just return true, indicating that it should pause the debugger. And then for the output, maybe we get our planet list, and maybe I want to return true if the results are empty. So these are ways that we might want to pause under certain conditions. And I'm just going to delete this last block because we're not going to use it. So we can run this and see what this looks like. So you can see that the Xcode did stop our running program and opened up the debugger, but we're kind of over here in no man's land. There's nothing in here that is really useful to us. And the stack trace isn't so useful either. We can sort of go back and see, okay, publisher.assign is in here. And if we go back to our view controller, which is our code, we can see that this is where the subscription was set up. So this is kind of unsurprising that it came from here. But other than that, there's really not that much useful information. It's also not obvious which of these is the one triggering this. But in our case, we can sort of deduce that because this is where it came from, that it's actually receiving the subscription. Now, because we never saw any output earlier, this is actually not going to trigger either. And in fact, this API never gives you results that are empty. But this is just an example of when you might want to return something that's a little bit more dynamic based on the input that you're getting. So because of these reasons, this breakpoint operator really isn't that useful in practice. There's also no receive cancel. So I can only breakpoint on subscription, output, and completion, but not cancel and not demand. So it seems kind of odd that this was added because I have never found an actual use for the breakpoint operator. There's also breakpoint on error. So maybe if you don't expect errors to happen, or if you just want to know if it's happening so you can fix it, maybe breakpoint on error is useful. But again, I haven't really used that. Instead, I think it's probably better to use handle events to do the same thing, because here we can say receive subscription. I get my subscription in, and let's just delete the rest of these for a moment. And here I can maybe print out the subscription, and I can set a breakpoint. And so here I'm using the standard breakpoint that you find in Xcode. And if I want to make it conditional, I can do that here. I can say, okay, if the subject has a combined identifier of something or whatever it is, I can add my conditional logic here in the breakpoint itself. And if I run this again, now the Xcode is going to stop on this line of code and allow me to interact with the objects that are inside of this block. So I feel like handle events is just a much better approach for this particular type of debugging. Another approach we've seen is to use print. And I think it's useful to give our print statements a label because especially when you want to mix these and have multiple print statements at different areas in your pipeline, it might be nice to be able to distinguish them from each other because the output can be quite wordy. So if we run print fetch on here, we can clearly see the problem. Fetch is receiving a subscription, it's requesting unlimited values, and is immediately canceled. And you probably already spotted the error. That's because we're not hanging on to the cancelable that comes back from here. In fact, I'm explicitly ignoring that. So if I delete this and change this to store in cancelables, and we run it again. Okay, so here we can see the results of our fetch. If I toggle that, we can probably see a little bit better. Fetch received a value. Here's our planet list. So there's 60 planets, and here's the first page of results that we're fetching. So the print debugging is really, really useful and can show you tons of information about how everything is behaving. Also, where you add print is going to change sometimes the output that you receive. And so we've seen this a few times in this course already. So just keep that in mind. So right now it's only fetching a single page. And I also have this other function, fetch planets. And the idea of fetch planets is that the end results will give us just a full list of all of the planets. And so it'll start off by fetching the page that we pass in. And then when it gets the results, if there is a next page, we're going to return a publisher to fetch that page. So the idea is it kind of recurses. And so this will call fetch planets and pass in a URL, and it'll just kind of continue. And if there is no last page, we'll return the results. So we can give this a try and see if this is working. So if I change this to just fetch planets and pass in that page, we no longer have to map these to results because that's going to be done already for us. And so if I do that, I can assign to planets, which is a local property. That will call reload data and reload our table. So if we run this, we can see what's going on. And now I've clearly broken it. And we can see that we're requesting unlimited values. Our subscription is active. It never gets canceled or completed, and no values ever come. So already print is really helping us sort of identify that there is a problem, and we've already ruled out the fact that it's not being canceled. So what is the problem? I'm going to hit stop there, and I'm going to add another print here. This one is going to be the page, and I'm going to actually pass in the URL of this page. And again, this is how we can leverage dynamic data to distinguish between multiple print statements, because we're going to be calling this multiple times. So if we run this again, now we can see a lot of output, and it's just continuing. So I'm just going to pause because we need to take a moment and see what's happening. You can see that we're getting a subscription for this page. It requests unlimited values. It finished. And then we received another value. So you can see that there's actually lots of these happening, and the URL is always the same every time. So it looks like it's just recursively calling the exact same page every single time in a loop. So I'm going to stop this, and let's go take a deeper look at this method here. We can see here that we check to see if the next page is not nil. Then we call fetch planets, and we're passing in page here, which is the page we started with, not the next page. So what we need to do to fix this one is grab next page, unwrap it like this, and pass in next page like that. Now we can see clearly that multiple pages are being returned. We get all the way to page 6, we receive finished, and we get some planets here, but now the planets that we get are only the final page of planets. So we have another problem here, but I think this is a good way to show how using print with some dynamic data can really help you identify what's going on and seeing how your pipelines are behaving. So to fix the rest of these issues, we'll take a look at a third-party tool called TimeLane in the next video. So let's fix this other problem. To get some more insight into what's happening with our pipelines, I'm going to lean on a third-party tool called TimeLane. Now you can find TimeLane at timelane.tools, and what this does is adds a nice instrument plugin to the Instruments app and allows you to visualize what's happening with your publishers right within Instruments. And so it can give you kind of a visual representation of when things are starting and stopping and when they're delivering values. So once you've downloaded TimeLane, you'll see this screen here where you can run this to install the instrument. And then if we go over to the Combine tab over here, you'll notice this also works with RxSwift. But the Combine tab will give you this URL here for the package that we can add. And I'm going to copy that, and then we're going to go back over to our project. So we'll go over here to our project, and then click here to go to our project, and then Swift Packages. And we're going to paste in TimeLane Combine. We'll link it with our project, and we can see that this pulled in TimeLane Core, which is kind of core stuff for adding stuff into Instruments, and then TimeLane Combine, which hooks it into Combine Publishers. So we can go over to our view controller now, and at the top here, we can import TimeLane Combine. And now we have access to an additional operator which we can use called lane. So I'm actually just going to change our print statement to a lane statement. So this is going to essentially send information to TimeLane, the TimeLane instrument, if it's running, and give us some useful information about what's happening here. I'm also going to do the same thing here and say lane like that. So at this point now we can run our application, but I want to run it with instrumentation, which is Command I. So when we do that, it opens up Instruments and asks us to pick which instrument do we want to profile our application with, and you'll notice there's a new one here called TimeLane, and I can choose that one. So this brings up the Instruments application, and it's waiting for us to launch it with this record button up here. And this is going to record a session and show us information in these lanes right here. And each one of these gives us some different information. So this shows us the subscriptions that are happening. And as you'll notice, it'll sort of draw a bar for each one of them. And they'll be colored green if they are running, blue if they're completed, and red if they're failed. And then events over time, you'll see little blips that happen here. So we'll do a quick recording. And because our application automatically fetches everything, we'll be able to see what's going on without having to actually click on anything. And so that's my sample. And I clicked stop. And now I just want to kind of zoom into this. I'm going to hit Command plus and move over here. So as you can see, there were 7 total subscriptions that happened, or at least that we notified TimeLane about. And as we kind of drag our playhead across the timeline here, you can see when each one, when each one is active. You can see that it completed. It also tells you how long it took. So you can see that this first one took 633 milliseconds to fetch this, and it did complete. The overall fetch took 4.71 seconds, so it's kind of long. Something might be going on there. And so you can kind of see what's happening with each one of these. You can also see the individual data elements that they emitted. So you can see that this one outputted this output right here. You can see planets outputted, planet list 60. It's kind of hard to read here. And so we can actually customize that if we want to. So we can see that this all comes from the page lane call. And so let's see how we can customize that. So right here, we are specifying which page we're fetching. And we can also output some of the data that's coming out of this. And so what we can do is add the transform value block here, which gives us back the data. So I've got our planet list, and our goal here is to return a string. So we'll get results. We'll map each planet to its name, and then join that with a comma. So that'll return a comma-separated list of all of those, and I'm missing the separator prefix there. Now we run it with Command I. We'll go back over here and we will click the record button again to record a new version. Okay, so you can see our pipelines are running and now they're all done. So I'll hit stop. And now you can see the output that we're getting from each of these is a little bit easier to read because we use that transform value. So we can see that this first page returned the results Tatooine, Alderaan, Yavin 4, Hoth, Dagobah, etc. Page 2 gave us this, page 3 gave us this. And so here you can clearly see that the output that we're getting, if I go back over to our running application, the output that we get here starts with this list here: Muriel, Sereno, Concord, Dawn. So we're getting the results from page 6, as we can see by examining the output here. So this is kind of what we're trying to figure out what is wrong. And in addition to that, we can kind of see that this is taking quite a long time. And this is something that sometimes isn't so obvious unless you're profiling to see exactly how long the entire thing took. And so we definitely need to figure that out. But first, let's figure out why we're only getting page 6 in the results. So I want to focus on this flat map operator again. Here we can see that if we get a next page, we're just flat mapping to the next page's publisher, and we're only getting the results from the last page here. So it's kind of, now that we've seen it, it's kind of obvious. So what we want to do here is we want to take the current results that we have. So we'll say just list results, and we want to take that and combine it with the results from the next page. So one way we could do that is to merge this publisher with the other publisher. So if we were to just zero in on this particular publisher that we are creating here, this is a merged publisher that takes the planets from this one with the planets from the next page. And so we want to basically get those results combined as one array rather than two events, each with an array. And so what we want to do now is take those, and we can use scan for this. This might be a good use of scan. So we can start with an empty array, and then we'll get this will be the total planets, and this will be the page planets. And so we can say, let's grab the page, or let's grab the total and append the page planets onto the end of that. And we can get rid of this because that will be inferred. So if we've done this, now we've got a scanned publisher, which starts with an empty array. And every time it gets a value, so first it'll get this value here, it'll add it to the empty array, so we'll get just the first page. And then when this one comes back, we'll add its results to it and emit the results. So maybe I can say erase to any publisher here and return this. Okay, so we run this and we'll see what happens here. And notice we get results really quickly, but it's still running. And now we can see we have quite a few results. In fact, probably too many. This looks like a lot more than 60. And if we look a little bit closer, we can see that, there's Tatooine and Geonosis. There's Geonosis again. And so as we keep going through, here's Dantooine, Geonosis again, Dantooine. So we're getting lots of duplicate results here. Now, again, you may already have figured out the result here, but again, we can probably add in a lane here, which could show us, something that's going on for that particular page. So here at this point, I want to make a lane called scan, and then I want to build this for instrumentation again. Flip over to instruments and hit the record button. Okay, now that that's all done, zoom in on these results a bit. If I look at subscriptions, we'll see the subscriptions. If we look at the events over time, that's what I want to pay attention to right now. So you can see that the first page outputted Tatooine, Alderaan, etc. Then it passed those results to scan, and those same exact results were output to the fetch lane. So going back over here, we can see that the results from the first page, that's this one, were added to scan and emitted downstream, which meant that fetch got that first page immediately. And we saw that in the results. We saw that the first page was sent back immediately. Now, if we look at page 2 outputs, and you can see that scan outputs page 2's results and then combines that with the page 1 results. And then those are passed to fetch again. So you can see that fetch received Tatooine again, and that probably shouldn't have happened. Now you might be tempted to just say, oh, well, maybe I just don't need the scan in here. So if we comment that out, and I'll comment out the lane as well. So we're just taking these results and merging them with the next page. What we'll see in this particular case is we see the pages being replaced every time. So we saw page 1, page 2, page 3, and they're just replacing them. So there's nothing that's kind of combining those results into one single array at the very end, which is what we want. And so scan seems like it's working, except that I want to wait for the final total. So I don't want to get the scanned results with this first one. I want to wait until it also fetched the next page before it starts adding them to an array and sending them downstream. So in this particular case, we can take the last results out of this, which is going to be one array with all of the items in it. So now you can see when we run it, we have all 60 planets in here, and there are no duplicates. So this is certainly one way we could solve this problem. And as with combine, we'll find that there are many ways to solve different problems. In this case, we may have also decided just to call flatmap, which gives us, so let's delete the merge and the scan code. In this case, we can take this results and flatmap it. So that's this page results in. And then I want to flat map that to get another publisher, which is going to get next page results. So here we can say self.fetchPlanets for the next page. And here I want to then map this one to some results. So this is next page results in. And here we can return page results plus next page results. So it does get a little bit hard to read because we've got kind of nested flat maps in here. But if we're just kind of zeroing in on one page and we're talking about getting this page plus the following page, which is an asynchronous, publisher, and then we merge them together. And because this is recursive, it jumps up here. So page 1 is going to merge page 1 results and wait on page 2's results. Then page 2's results are going to get its results and wait on page 3's results. So basically it's going to wait until it gets all the way to page 6, where it just emits a single results array. And then it's going to sort of bubble back up to page 1, combining everything as it goes through inside of this block here. So let's give that a run as well. So you can see it takes quite a bit longer, but we get all of these results. Now, the problem that I want to talk about now is, why is it taking so long? And as we saw in one of these runs, if we take a look at these subscriptions and we look at the duration here, this is the overall value here. And so we just look at the fetch ones. We can ignore the scan ones for now. We can take a look at the page to see how much each page took. So that took half a second. It took 167 milliseconds. And then this one took 3.45 seconds. So for some reason, page 3 is the culprit. And you might be able to see that also in the timeline. If you kind of zoom out, the longest one that we have is this one. And so, that can give us some indication that we need to go investigate what's happening with page 3. So if we go back over to the source code and maybe we just search for 3, and I find this code down here, way down at the bottom, kind of hidden. It's called secret operator, and it is incrementing a global counter. And as soon as it gets to 3, it delays for 3 seconds. So obviously we just want to delete this code because it was snuck in there and causing havoc on our publisher. So I do that, and that means that we need to delete the secret operator here. And if I've done that now, it should be quite a bit faster. Okay, there we go. We get all 6 pages, all in one array. So that's a look at using TimeLane to add some visual debugging for our pipelines.
Okay, you've reached the end of the course. We've come a long way and we've learned a lot about Combine, and you should be proud that you stuck with it until the end. As I said in the beginning of this course, learning Combine is most effective when you actually sit down and do the examples and you practice on your own. And this is where I would encourage you to continue your exploration of Combine and try to solve some real problems with it. If you get stuck, you can always reach out and ask for help. Speaking of help, I would encourage you to post any questions you have about Combine or any problems you get stuck with, to post those to the Swift forums. There's a Combine tag that you can use, and other people from the community can answer your questions, including me. If you do post a question on the Swift forums, feel free to email me or hit me up on Twitter, and I will do my best to answer it. If you'd like to continue your learning in book form, I can heartily recommend these two books: Practical Combine by Donnie Walls and the Combine book by the Ray Wenderlich team. I'll leave a link to both of those books down below. Learning Combine and making this video course has been a rewarding experience, and I'd like to thank you for taking the course. As always, I'm eager to hear feedback, so if you have a moment, drop me an email at ben@ficklebits.com and let me know what you thought about the course. That's it from me. Take care.